In Learning Target 3.14, we will calculate the mass of the reactants and products from the mass of another reactant or product. And this is using the concept we've called grams to grams. Now, in this example, we have an equation. It gives us 2KClO3 yields 2KCl plus 3O2. The question asks us how many grams of O2, which is right here, can be produced by letting 14.0 grams of KClO3 react, which are right here. So all of these grams to grams questions are going to be what we call like 3 steps or 3 conversion factors. We're always going to start by writing our known value, which is 14 grams of KClO3. And we know that at the very end, the numerator in our last conversion factor is going to be grams of O2 because we are trying to find that. So we're going to need to actually use 3 different conversion factors for every time we do a grams to grams question. Now make sure that the units in our numerator are always going to match the units in our next denominator. So we have to have grams of KClO3 right here. And this first conversion factor is going to be the molar mass. So we know that we're going to have 1 mole of KCl3, which is equal to 122.5 grams. And we got that by adding the mass of each individual element, including 3 oxygens. Next, we know that this is moles of KClO3, so we must have moles of KClO3, which is our known value. And we're going to use this molar ratio right here to go from moles of KClO3 to moles of O2. And if you remember, in these blanks, we need to include the coefficients. So there's a ratio of 3 to 2. For every 2 moles of KClO3 that react, 3 moles of O2 are produced. And again, here we're looking at the coefficients. Now we want to end with the molar mass for O2. So if we have 1 mole of O2, we know that's going to be equal to 32 grams. Now you can check your work by making sure that everything simplifies. So we know that we're going to cross off the units, and that looks correct. And we can do some simplifying. Why don't we take our 2 and change this to 7 over 1. And then let's rewrite that. So 7 times 3 times 32 all over 122.5. Now, I'm going to use a calculator for this. On the CST, don't forget that you'll have very easy numbers to multiply with and divide by. So just to take your time, show all your work on the CST without a calculator. But if you do the math here, you would get 5.5. And again, our units are grams of O2. So again, you're always going to multiply by 3 different conversion factors in a grams to grams question. First, you're going to have your known value, and you're going to divide by the molar mass for that known element or compound. Then you're going to use the molar ratio to convert, from moles of your known compound to moles of the compound you're trying to find using the coefficients. And lastly, you got to have moles of O2 down here, and you're multiplying by the molar mass, which you find by looking at the periodic table. Cross off your units, simplify, and then show the math to get our answer. Now I'm going to scroll down here to an individual example for 3.14. Maybe pause the video, work this one out on your own using the notes we just took down, and resume watching when you're done to check your work. So here's the work for this question. Again, we start off with our known value, which is 96.8 grams. We divide that by the molar mass of H2S from the periodic table. we know that we're going to next have to have our molar ratio, and that's actually just a 1-to-1 ratio between these two compounds, H2S and ZNS. And then we need to cancel our units, moles of ZNS, and we do that by ending with multiplying by our molar mass on the top. Again, these numbers are not easy to work with. They will be very easy on the CST, but you'll get an answer of about 275, 276 grams of ZNS, or zinc 2 sulfide.